Hey everyone! In this video, we will talk about CRC error detection and error correction. CRC stands for Cyclic Redundancy Check. Before going to CRC, we will understand what cyclic codes are. Cyclic codes are special linear block codes with one extra property. In a cyclic code, if a code word is cyclically shifted, rotated, the result is another code word. CRC is a method which is used to detect errors in data transmitted from the sender to the receiver. This method not only detects errors, but also fixes them. Why CRC? If you were to send a message to your friend, only your friend would receive it and not anyone else. If your friend is the one who's receiving, only he needs to decode it. Why to encode it? Because devices don't understand how we message someone. We can understand, but the devices can only understand binary language. While this process happens, your friend sometimes doesn't get the message because of an error in data transmission. This is where CRC comes in clutch. Let's understand it through this diagram. In this diagram, we can see that how a data word is encoded into a code word and it is finally sent to the receiver. Once the receiver gets the code word, it is decoded into the data word which we sent. But in this process, errors can happen and data word received would be different, just like how your friend doesn't get the message that you sent. First, we will learn how we can encode it and decode it. And then we will see how error is detected. Consider that your message is 101101. You need to encode it somehow. We will use 1101 to encode it. We will take the data word 101101 as dividend and 1101 as divisor. In this division, we don't subtract. Instead, we will do X or operation. We need to append a couple of zeros at the back of the dividend to make sure our code word is properly coded. How many zeros to append? Well, we need to append n-1 zeros, where n is the total number of digits of the divisor. In our case, we have total 4 digits in our divisor. So, we must append 4 minus 1, which is 3 zeros. Now, if your first digit is 1, multiply the divisor by 1 and do the XOR operation between them, just like this. Refer this XOR table for the XOR operation. Note that we are not taking the first bit after XOR operation. Instead, we are taking the last 3 bits, because the first bit will always become 0. Once you are done with the XOR operation, we will bring down the next bit for the next XOR operation. Here the first digit is 1 again. So we shall multiply the divisor by 1 and do the XOR operation just like this. Once that is done, we will bring down the next bit for the next XOR operation. Here our first digit is 0. So we shall multiply the divisor with 0 and do the XOR operation. We will continue this process until we finish up all the bits of the dividend. We finally got our remainder, and the remainder that we got is 010. But how do we make our code word? Take the data word and the remainder and combine them together. This is your code word. How do we decode it? If we use the same divisor to divide the code word, we will get our data word back. Make sure you get 0 as your final remainder. If you don't get your remainder as 0, you will likely have an error in the code word. That is where CRC error detection comes in play. CRC error detection will check errors by decoding the code word, and if the remainder or the syndrome value is not 0, the code word is wrong. This implies that the receiver didn't get the right message or didn't get decoded properly. This error can be a single bit error or a burst error. CRC can identify the error during the decoding process. Consider we get a single bit error like so. Let's try decoding it. Let's set up the division and start dividing it. After doing the division with XOR operation, the remainder is found out to be different than 0. This wrong code word is rejected and sends an acknowledgement to the sender to send the data once more. Easy, right? Well, if you were given a data word like so, the data word wouldn't probably be encrypted with a simple divisor. To encode the data word, we would be using a generating function, or more like with a polynomial. But how can you encode it with that polynomial without a divisor? Here's how you can do that. First, rewrite the polynomial by writing the coefficients of each term. Then, extract only the coefficients of the polynomial. You will get a binary sequence 10101. With this binary sequence, you will be able to encode the data word by doing the CRC division with XOR operation. This extracted binary sequence is your divisor, and use that to encode and decode the data word. Now that you know how to perform that, try this question all by yourself. Here's a CRC table containing both data word and code word. And the polynomial function used here is this. When we convert the polynomial into the binary sequence, you would eventually get the divisor, which is used to encode the data words in this table. We hope you understood. Feel free to reach out to us if you face any issues solving the problems on CRC. Thank you. See you all next time.